Hello, my name's Tim Rolling and I'm the Managing Director of AuScope. You'll notice that I'm not in a geological or laboratory-inspired location as I talk to you this year. In fact, I'm stuck in my 25-kilometre isolation bubble in Melbourne with a very familiar backyard space in this transformative year of 2020. While COVID has impacted all of our teams in their ability to undertake fieldwork, access remote equipment, or even get into their labs, I hope you'll see that it has been a very good year for the AuScope community. Since 2007, we've invested in research infrastructure ranging from radio telescopes to microscopes and seismic arrays to simulation platforms. Most recently, we brought the Australian geoscience community together to help us imagine what the next decade should look like for AuScope and how we can best support the novel and important research that this community undertakes. During Earth Science Week this year, Chris Pygram, Joe Condon and I were very proud to release the culmination of this conversation in the form of two documents, the AuScope 10-year strategy and 5-year investment plan. The 10-year strategy outlines 7 overarching goals that would guide all our corporate activity over the next decade. These are to enable geoscience innovation by building the Australian downward-looking telescope, to develop a national predictive geoscience capacity, to foster a connected community, to create strong, meaningful Indigenous engagements, to improve understanding of our nation's groundwater, mineral and energy services, and to develop a global research capability for the geosciences. The Downward-Looking Telescope, or DLT, is the overarching concept that has been endorsed by the community to guide future AuScope investment decisions. It will be an integrated capability like a telescope that will allow researchers to see deep into the Earth. The 5-year investment plan details the specific infrastructure elements that it entails. AuScope currently has secure operational funding until 2023 through the National Collaborative Research Infrastructure Strategy. In the 2020 federal budget, the government committed to continue to support NCRIS, as well as committing to fund the 2020 Research Infrastructure Investment Plan. As a result, AuScope will receive nearly $6 million in 2022 for capital refresh. This will provide us with an opportunity to replace some instruments and invest in new programs as part of the DLT. Speaking of new funding, thanks to the team at Curtin and the Geological Survey of Western Australia, the WA government this year announced a $3.2 million co-investment in a new geoscience iron probe, towards which AuScope has committed $5 million. An order has been placed for a new instrument, which will be delivered in mid-2021. This year, we also kicked off the Curnamona Deep Earth Imaging Project. This will deploy the Curnamona Cube and the Curnamona Supersite, which will collect long and ultra-long time series magnetotellurics, passive seismic, and heat flow data, providing insights into the structure of the deep crust, changes to the groundwater system, and the nature of crustal heat flow. This represents the first integrated geophysical deployment of this type in Australia and will provide a benchmark for the design of the DLT. The AuScope Geochemistry Network has grown the team to 19 people who are engaging deeply across the Australian geochemistry community and preparing to release a beta version of the AusGeochem data analytics platform. We have also developed a new geophysical monitoring capability with the acquisition of a suite of nodal seismometers at ANU, which are capable of recording seismic noise at local scale, imaging geological features like faults and aquifers. In collaboration with CSIRO Mineral Resources, we have containerised the multi-scanner core logger. This will allow this valuable instrument to be moved around the country to drill core storage facilities, reducing handling issues and significantly increasing utilisation and impact. 2 AuScope Opportunity Fund pilots have started, the National Argon Map with ANU and Geoscience Australia, and the Heat Flow Data Project with the University of Melbourne and the MinEx CRC. Additionally, 7 new Opportunity Fund pilot projects have also recently been announced, which will develop fair geospatial data and analytics, geophysical monitoring in Antarctica, mineral isotope analysis, and collaboration on critical zone observatory development. In collaboration with ARDC, TERN, APPF, Monash, CSIRO and Geoscience Australia, we launched the Australian Scalable Drone Cloud to standardise how Earth and environmental scientists collect and analyse drone data by establishing best practices and fair data principles. Also, members of our simulation and modelling community collaborated with scientists from MIT to deliver a panel discussion on utilisation of Earth observation data in simulation at the International GeoWeek conference, and the outreach team at AuSCIS inspired the next generation of young women to become geoscientists at the GEMS event in Canberra. In science news, AuScope infrastructure continues to enable diverse and exciting research. An international team of volcanologists, including Curtin geochronologists, married 21st century dating techniques with Bronze Age footsteps and cave paintings from Turkey's Kula UNESCO Geopark to confirm one of the oldest demonstrable human sightings of a volcanic eruption. Researchers were also able to analyse samples from Vesta, the second largest asteroid in the solar system, and show that it was volcanically active for at least 30 million years after its original formation. Quite a remarkable discovery. Researchers at the University of Tasmania have developed innovative techniques to use AuScope VLBI telescope data to underpin global sea level rise calculations. The AusLAMP Magnetotellurics Geophysics program at the University of Adelaide was for the first time extended beyond the coast with a deployment of novel MT sensors on the seafloor in the Spencer Gulf. Meanwhile, the ANU team are currently deploying the AuScope ocean bottom seismometer fleet across the Macquarie Ridge between Australia and Antarctica. Researchers from across our 3 simulation, analysis and modelling nodes help map the location and mass of life forms living deep in the Earth today across the globe, and more accurately simulate the migration of carbon dioxide plumes through rocks. Researchers at Curtin have developed potentially game-changing exploration techniques that utilise rutile as a potential pathfinder for the discovery of critical mineral deposits. And in one of the few upsides of the COVID shutdown, the ANU seismology team were able to use the AuScope broadband seismometer network to monitor the Earth's more subtle seismic signals, usually obscured by the noise of human activity. So while it's been an unconventional and trying year, it's also been productive. With a new strategy, some new funding, and optimism about the future, we look forward to creating the new AuScope that our community has imagined and working together to build the DLT.